Hello, and welcome to this read through, or rather exemplified read through of datetime type in standard library. So we had covered till here, and we will continue after that. So operations which are supported on date types are: you can add time delta or subtract it. You can subtract two dates. Subtracting two dates will result in time delta object. You can check for equality and non-equality, as well as you can do greater than less than comparison for between two dates. Now there are some notes here. Date 2 is moved forward in time if time delta dot days is greater than 0, or backward if time delta dot days is less than 0. Afterward, date 2 minus date 1 is equal to time delta dot days. Time delta dot seconds and time delta dot microseconds are ignored. Overflow error is raised if date 2 dot year would be similar than min year or larger than max year. So the thing here to understand is why time delta seconds or microseconds are ignored. So if you remember our discussion of the previous video, let me show you time delta object. Give me a moment. What I was referring to is, okay, so when we store a time delta object, we will have days, seconds, and microseconds. Now date object, if you look at, that has year, month, and days. So days will operate accordingly. If you add days, date will move forward or backward. That is, you are adding or subtracting a time delta object. But days here are whole numbers, so seconds won't have any impact, because seconds in a time delta object will be always less than 86,400. If you add two time delta objects and add that to date, so that your seconds might be more than 86,400, then what would happen is that will be converted to days. So essentially, in the end, the seconds and microseconds do not make a difference when you operate with date and time delta. Right. The second note is that time delta is what we have covered. This is exact. Third one is exact. Okay. And cannot overflow. Time delta dot seconds and time delta dot microseconds are 0. Date 2 plus time delta is equal to date 1 after the operation. Date objects are equal if they represent the same date. Date objects that are not also date time instances are never equal to date time objects, even if they represent the same date. So this you have to be careful about, okay, because date time instances will never be equal to date objects. Date 1 is considered less than date 2 when date 1 precedes date 2 in time. In other words, date 1 less than date 2 if and only if date 1 dot 2 ordinal is less than date 2 dot 2 ordinal. Order comparison between a date object that is not also a date time instance and a date time object raises a type error. So these you have to be careful about when comparing with the date time or overflow or underflow. Now I do not remember that we discussed two ordinal. It may come later after what we have. Okay, we'll see two ordinal. Here is the two ordinal function. Then we have instance methods. So what we have covered till now is basically class attributes. Now we will cover the object functions which you invoke on an object. The first one is date.replace. It takes arguments as year is equal to self.year, month is equal to self.month, and day is equal to self.day. Return a new date object with the same values but with specified parameters updated. So if you don't provide any parameter, it won't be updated. But suppose we constructed a date with the object year 2002, month 12, and days 31. Now if you specify day is equal to 26, it will change to 26 December 2002. The generic function copy.replace also supports date.objects. Date.time tuple return a time.struct time such as returned by time.local time. The hour, minute, seconds are set to 0 and BST flag is -1. So if you want to convert it to such an object, you can do that. Now here, y day is equal to d dot to ordinal minus date d dot year 1 comma 1 to ordinal plus 1. That is the day number within the current year, starting with 1 for January 1st. Now we look at 2 ordinal. Return the proleptic Gregorian ordinal of the date, where January 1 of year 1 has ordinal 1. For any date object, d date dot from ordinal d dot to ordinal is equal to d. So let's take an example here, okay, from Gregorian ordinal, okay. So let's create an object dt dot date, and we want to create 1917 comma 1 comma 1, okay. So that is our date, and we assign it to a variable, say epoch, that is the Unix epoch time, okay. Now if we say epoch dot to ordinal, then it will be 719,163. Now we create another date starting from 0. Okay, we create one first year, okay, and then we say epoch dot to ordinal, that will be 1. That is 81 January 1st and day 1. That is where our date counts starts, okay. So that is what is the meaning of to ordinal. Sorry. So where were we? Here. Now date dot weekday will return the day of the week as an integer, where Monday is 0 and Sunday is 6. For example, date 4th December 2002 dot weekday will be equal to 2. A Wednesday. See also as a weekday. ISO weekday returns the day of the week as an integer, where Monday is 1 and Sunday is 7. So the difference between weekday and ISO weekday is that weekday starts from 0 and ISO weekday starts from 1. Then we have ISO calendar, which returns a name tuple object with 3 components: year, week, and weekday. We have not yet covered name tuples. So they are like tuples, but they are more like also like dictionary. You have some names for that, for every object in the tuple. The ISO calendar is a widely used variant of the Gregorian calendar. The ISO year consists of 52 or 53 full weeks, and where a week starts on a Monday and ends on a Sunday. The first week of an ISO year is the first Gregorian calendar week of a year containing a Thursday. This is called week number 1, and the ISO year of that Thursday is the same as the Gregorian calendar. For example, 2004 begins on a Thursday, so first week of ISO year 2004 begins on Monday 29th, 2003 and ends on Sunday 4th January 2004. So that is the example we have been shown. Now if you want to see what was the weekday of the first year of the first month, then we can say that epoch dot weekday, okay, and that was 0. And if you look at ISO weekday, that would be 1. So that is a Monday. Okay, now we look at date.iso format. If you format in ISO format, it will be YY minus MM minus DD. Then we have the str function to do the string representation, which is equivalent to ISO format. Then we have the ctime. Ctime function will represent the string representing the date. So d.ctime is equivalent to time.ctime, time.mktime, d.name tuple. So from the name tuple you create a time, and then you invoke mktime on that, and then you finally invoke ctime. So if you remember, name tuple will contain only year, week and weekday. Sorry, time tuple we have not discussed. This is different. This is not that. So time tuple, I believe, let me find it quickly. So we have here Okay, so time tuple represents stuck time. Okay, so if you want to see what stuck time represents, let's quickly take a look at it. It contains tm underscore year, tm underscore month, tm underscore day, tm underscore hour, minute, second, weekday, year day, is DST, zone, and GMT off. So that we pass to the tuple here, sorry, mk time, and that converts it to c time. So it looks something like this. On platforms where the native ctime function, which time.ctime invokes, but which date.ctime does not invoke, conforms to the C standard. Date.strftime, which is a format, return a string representation of the date controlled by an explicit format string. Format codes referring to hours, minutes, or seconds will see zero value. So strft time, I'm not sure that we have seen. We can quickly, okay, it is given in that. This module itself will have that. Then we have date.format, same as date.strft time. This makes it possible to specify a format string for a date object in formatted string literals, and when using str.format, and we will look at strft time. So we have some examples. We import time, we import datetime as dt, and we create a today object, dt.date.today, and put it in today. And when the documentation was written, it was 2007 December 5th. And then from timestamp, it is creating another date, okay, and the timestamp is time.time, that is now, and you are comparing it to today, which will be equal. Then we create another date object, birthday, which would be today.year, and 6.24th, that is 24th June. If my birthday less than today, then my birthday is equal to my birthday dot replace year is equal to today dot year plus 1. So my birthday will advance to 2008 because birthday was 24th June and today was 5th December. So it was less than today, and therefore the date, the year got increased by 1. Then you convert you calculate birthday minus today, and then you take the absolute value, and then that would be the number of days which are remaining to reach the next birthday. So from my birthday would be 2008 24th June, okay, that is this, and then you subtract this and you get number of days. You take absolute value, you get 202. Then another example is given. So from ordinal, it has put 730,920th day from the epoch, not epoch, not Unix epoch, the beginning of AD. So first of January 1. So the date, this many days after that would be 2002 11th March, and then it prints in ISO format. Then you have strft time, %d, %m, %y, and slash is the separated, so that is 110302. Then you strft in %a. So these format specifiers you will see, no need to worry about that. And this will also require formatting stuff. Then you create a time tuple, and for each name in the time tuple we print the year, month, day, and weekday, and other things which we have seen. Then we have ISO calendar, and if you want to print every member of the ISO calendar, you get year, month, and day. And finally we see that if you do a replace, then we produce a new object. So let me show you an example. Okay, so we have epoch here, epoch we have created, and then we say epoch dot replace, we say year is equal to 2026, and if it is mutable, the date of epoch will change. Okay, but if you see epoch, it has not changed that. So date objects are mutable. And then we have datetime objects. So datetime objects are quite similar to date objects, but they also contain hour, minute, seconds, and microsecond TZ info. So these are the extra pieces of information contained in datetime, and behavior is quite similar, as you will see. Like a date object, datetime assumes the current Gregorian calendar extended in both directions. Like a time object, datetime assumes there are exactly 3600 multiplied by 24 seconds in every day. So here we have the constructor call, the year, month, day you can supply, and hour, minutes, seconds, microseconds, TZ info are optional. So year, month, day are required, TZ info may be none. So if you supply none, it will be a nav datetime object. Okay. So this TZ info can be an instance of TZ info class, which we will see later. The remaining arguments must be in the following range. So min year, year should be between min year and max year, month should be between 1 and 12, day should be between 1 and less than number of days in the given month and year, hours between 0 and 24, minutes between 0 and 26, seconds between 0 and 26, and microsecond between 0 and 1 million, and fold between 0 and 1. So now we move forward, and the exception value error is raised if any of the arguments are outside the range of these supplied specified values. Then we have class methods. So there are other constructors are also there. So one is today, which will create a datetime object from the time information of current moment. So it returns the current local date and time bits TJ info none. Then this method is functionally equivalent to now, but without a TZ parameter. So now is another constructor which is TZ is equal to none. It does the same thing as today. If optional argument TZ is none or not specified, this is like today. But if possible, supplies more precision than can be gotten from going through a timestamp. For example, this may be possible on platforms supplying the C gets time of today function. If TZ is not none, it must be an instance of TZ subclass, TZ info subclass, and the current date and time are converted to TZ's time zone. This function is preferred over today and UTC now. Then we have UTC now constructor, which returns a UTC date and time with TZ info. This is like now, but returns the current UTC date and time as a nav datetime object, and our current UTC date time can be obtained by calling datetime.now timezone.utc. Now we have a warning: because nav datetime objects are treated by many datetime methods as local times, it is preferred to use aware datetimes to represent times in UTC. As such, the recommended way to create an object representing the current time in UTC is by calling datetime.now timezone.utc. And one more thing is that it has been deprecated, and datetime.now uses UTC. And right now our Python version, as you can see, is 3.14. So we won't use UTC now. We will use datetime.now with the time zone UTC. Then we have from timestamp, so you can supply a timestamp and TZ is equal to none. That is another constructor. Return the local date and time corresponding to the POSIX timestamp, such as returned by time.time. If optional arguments TZ is none and not specified, the timestamp is converted to the platform's local date and time, and the return date time object is naive. That is, it won't have the time zone information. However, if TZ is not none, it must be an instance of TZ info subclass and similar stuff. From timestamp may raise overflow error if the timestamp is out of the range of values supported by the platform C local time or GM time functions, and OS error on local time or GM time failure. It is common for this to be restricted to years in 1970 through 2038. Note that on non-POSIX systems that include leap seconds in their notion of a timestamp, leap seconds are ignored by from timestamp, and then it is possible to have two timestamps differing by a second that yield identical datetime objects. This method is preferred over UTC from timestamp. Now we have UTC from timestamp constructor return the UTC date time corresponding to the POSIX timestamp with TJ info none. The resulting object is naive. This may raise overflow error if the timestamp is out of the range of values supported by the platform GM time function and OS error on GM time failure. It is common for this to be restricted to years in 1970 through 2038. Now, why do we have this restriction between 1970 and 2038? So let's see. So 2038 to 1970 is how many years? 68 years, okay? Now, if we multiply 68 with 365 multiplied by 86,400 seconds per day, you get this much, roughly, ignoring the leap years and all that. Now you look at this value, how much is this? This is 1000, and then we have million, and then we have billion, okay? Now in the old C code, what happens is that the struct time, that is the value of number of seconds which you store in C is 32-bit integer. If you look at 32-bit integer, it's assigned integer, that would be 2 to the power 31 minus 1. So that is roughly the same number of values. So it is because of the limitation of 32-bit integers. That is why we have 2038. But on some systems, that is on 64-bit systems, the integer 32-bit is now changed to 64-bit integer, long as such. So that is why this restriction does not affect all C programs, but certain C programs which are 32-bit. And that is why Python is also restricted to 1970 to 2038. Now, where were we? Okay, so here, to get an aware datetime object call from timestamp. So you supply the timestamp and we get timezone.utc. On the POSIX compliant platforms, it is equivalent to the following expressions. Datetime 1970, 1, TZ info is equal to timezone.utc plus time delta second is equal to timestamp. Now we are working on Linux mostly, which is a POSIX compliant platform, so it is true for us. So you don't see my panel and think it is Windows. It is actually WSL on which the code is running. Now we are warning because naive datetime objects are treated by many datetime methods such as local times. It is preferred to use aware datetimes to represent times in UTC. As such, the recommended way to create an object representing the specific timestamp in UTC is by calling datetime.fromTimestamp and we supply timestamp and time zone. Then we have another constructor which constructs the object from ordinal. It returns the datetime corresponding to the proleptic Gregorian ordinal, where January 1 of year 1 has ordinal 1. Value error is raised if ordinal is less than 1 and unless ordinal is greater than equal to 1 and less than equal to datetime.max.toOrdinal. The hour, minutes, second and microsecond of all the results are 0, TZ info is none. Then we have a combined constructor which takes a date argument, a time argument, and optionally TZ info. Return a new datetime object whose date components are equal to the given date objects and whose time components are equal to the given time objects. If the TZ info argument is provided, its value is used to set the TZ info attribute of the result. Otherwise, the TZ info attribute of the time argument is used. If the date argument is a datetime object, its time components and TZ info attributes are ignored. For any datetime object D is equal to datetime.combine d.date, d.time, d.tz info. Then we have from ISO format we can construct. So it returns a datetime corresponding to a date string in any valid ISO format with the following exceptions. Time zone offsets may have fractional seconds. The T separator may be replaced by any single Unicode character. Fractional hours and minutes are not supported. Reduced precision dates are not currently supported. Extended date representations are not currently supported. Ordinal dates are not currently supported or from ISO format. So we have several examples of ISO format. We take 2011 November 4th. So this is also number 4th. Then we have the hour and minute, and then we have seconds also 23, and then we have it in sorry, it was not hour 5:23, it is midnight, and then 5 minutes and 23. Same object, and this one also includes microseconds 283. So this is 283,000 microseconds, not 283 microseconds. 283 milliseconds are there. So it's the same object created in different fashion. Then we have another constructor from ISO calendar, which takes years, week, and day. It returns a date time corresponding to the ISO calendar date specified by year, week, and day. The non-date components of the date time are populated with their normal default value. This is the inverse of the function datetime.isocalendar. Now we have strp time, return a date time corresponding to the date string parsed according to format. If format does not contain microseconds or time unit information, this is equivalent to date time start time.strp time, date underscore string format. It takes slice of 0 to 6. Value error is raised if the date string and format can be passed by time.strp time, or if it returns a value which is in a time tuple. So we'll look at strfp and strp time at the end. Then we have the attributes datetime.min. So the minimum is min year 1 and other attributes hours, time, seconds 0. Then we have max. Max would be 999, and we have studied this already. We have resolution. So smallest resolution will be 1 microsecond. Then these were the class attributes. Okay. Now we have object attributes datetime.year, datetime.month, day, hour, minute, second, microsecond, and period info. Unfold in 01, used to disambiguate wall times during a repeated interval. A repeated interval occurs when clocks are rolled back at the end of daylight saving time, or when the UTC offset for the current zone is decreased for political reasons. The values 0 and 1 represent respectively the earlier and latter of the two moments with the same wall time representation. So now we have operations, that is, we can add date time with time delta and subtract. You can also subtract two date time objects. You can do equality comparison, and you can compare greater than or equal to, that is order comparison you can do. Note that you cannot add two date time objects, that is not supported. So I think we should stop here. It has been a long video. It should take at least 2 more videos to cover because it's a quite big one, as I said in the beginning. So we will start in the next video at supported operations of datetime objects, and we will continue as far as we can in roughly 20-25 minutes. And we will see there is quite a bit of information we have to go through. So we will start with the nodes of operations on timestamp datetime object. So I hope that you are finding this video useful and informative, or the entire playlist if you are watching the playlist. So we will meet again on the 4th day from now, and I thank you for watching the video. So do not forget to like the video and subscribe to the channel if you find it useful. So once again, I thank you for watching the video, and I'll see you in the next one. Till then, keep learning and enjoy.